Yes, we will now start the session right now. So I have told you that in Stata software or the panel data analysis, basically we can establish three types of model. And the name of the first model is pooled regression, or in some books, it is known as constant coefficient model, or popularly it is known as pooled regression model. So today, this is a very important session. You can understand how the pooled regression is established and whatever the result we will be getting after establishing the equation using Stata software, then obviously we will interpret all the results of our OLS model. So I will take a very small example so that you can understand in a better way. So just first I am showing the data set, and after that I will show you how the OLS will be established and how the results will be interpreted one by one. If you have some query, you may raise question and I will obviously give you the answer. So just give me time so that I can present the data set at first. First you understand the data set, then we will use the Stata software for establishing OLS or pooled regression model. The full form of OLS is ordinary least squares. Yes, this is our small data set, and we have taken three variables. One is investment, second one is export, and third one is income. This is a very small data set. So out of these three variables, obviously one variable is treated as dependent variable. So from our domain knowledge, we can say that income is our dependent parameter. Income is our dependent parameter. And investment along with export, these two variables are treated as independent parameter. So we want to establish pooled regression.
Dr. Saab, good evening.
Yes.
Dr. Saab, good evening. Satbir Singh this side.
Yes. Good evening.
Sorry, sir. There was some technical problem in getting the connection. Shivangi ma'am ne just now she sent me once again the link. So, sir, can you please repeat what you started?
Yeah. No problem.
Sorry, sir.
Just we have started. No problem. So today we will discuss.
आप डॉक्टर साहब लग रहे हैं आज. ज़्यादा सर्दी है क्या सर?
नहीं. Today we'll discuss.
Okay, sir.
One particular model, that is OLS, ordinary least squares, or in the first class I have already told you three types of regression equation we can establish. One is OLS, second one is fixed effect model, and third one is random effect model. So today we will discuss how to establish pooled regressions model or OLS, ordinary least square, or sometimes it is called as constant coefficient model. So for this purpose, we have taken a small data set, and this is our data set. What you are observing, out of these three variables, investment, export, and income, income has been taken as dependent variable and investment is taken as independent variable. Export is also taken as independent variable. So we are going to establish OLS by taking these three variables. One is our dependent variable, that is income. Investment and export, these are our independent variables. And we have taken some time variable 2001 to 2008. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 observations are there. Therefore, we have written here OBS, observation. That means we are observing 8 years. The span of time is 8 years. And we are observing three variables: investment, export, and income. And our intention is to establish OLS by taking income as dependent parameter and investment and export, this will be our independent parameter. So today we will discuss how to run OLS using Stata software. So I'm just closing this data file. Now I'm opening the Stata software. Yes, this is our Stata software. Now from this software, our first task is to import the data set. To import the data set. For this purpose, we will click on File, then go to Import option, then Excel spreadsheet, Browse option, then go to day 3, OLS in Stata. The name of the file I have given OLS in Stata. Just click here, then click on Open option. Then we have to click here because we have to specify the first row as a variable names. Always remember that. You have to click here. Then lastly, we'll click on OK for importing the data set into this Stata software. So we have already imported this data set into this software. Now the second function, obviously we can remember what is your second function. Your second function is to create the log file so that all the results will be saved, all the commands will be saved. That's why the second function is we have to use the log file. So what is the command? Log using
Inverted comma.
Yes, very good. Inverted comma. Then
File
please
name.
give name of the file.
Roy Sab.
Roy Sab.
नहीं ऐसा मत कीजिए.
Okay, no problem. Roy Sab. Dot. Then txt.
Inverted comma closed.
Inverted comma close comma. Then
Append.
text append. Yes, text append. What is the problem here?
Roy sir, I think Roy sir two separate words I think we have used.
Yes, yes.
I think you have used the text TEXT instead of TEXT.
Yes,
that is also
you are
there.
absolutely right. You are
Text append.
absolutely right.
Text append होना चाहिए.
Yes. यहाँ पर
It should be
TXT हो गया.
TXT.
TEXT. Yes.
Now it should be okay.
Yes.
Because within inverted commas it should not matter.
Exactly. You may give any name. Yes. So here it will be TXT, text append. So our log file is ready. Now, whatever the command, whatever the results will be there, it will be saved to that specific text file, and we have given the name Roy Sir. So now, first thing is we have to run the OLS using Stata. We have to run the OLS using Stata. Without using any command, I will show how this option, how these statistics, these options will be used for the analysis purpose, so that you cannot use the command, although you will get the same result. So what I will do, I will show you from this option. Again, I will show you by giving some specific command, both the result will be same. So one by one, I will show you. First, you have to go to statistics. Then for a regression equation for OLS, ordinary least square, you have to select the second option, that is linear model related, linear models and related under statistics. So statistics, then linear models and related, and after that you go to this option, linear regression. Basically, whatever the OLS or fixed effect model or the random effect model, whatever the model will be established, basically all these models are linearly regression. All these models are linearly regulated. That means a straight line equation we are assuming. That's why the name is given linear. Linearly related. So linear regression, just to click here. Now the software is asking, what is your dependent variable? And the software is asking, what is your independent variables, independent parameters? So just to click here. Then out of these 4 variables, one is your observation, time observation, investment, export, and income. So out of these 4, we are selecting income is our dependent variable. Income is our dependent variable. Now we are selecting our independent variables. One is investment and another one is export. One is investment, another is export. This is our independent variables, and income is our dependent variable. And then we'll just click on OK. And if you click OK, then obviously one regression equation you will get, and that is called OLS. So just to click on OK. And this table we have got by using the command from statistics. But if you directly give the command, then what would be the command? Regress. Yesterday I have told you, regress. Regress. Then you have to write the name of your dependent variable, income. Then followed by all independent variables. One is investment, and next one is export.
Sir, this investment and export, the is there any significance of the order in which we put it?
No, no order. We can also write export, sorry, export and investment, right? Export and investment. Then what will happen? The result of export will come first and the result of investment will come last. But here, when we use and when we give the name of the independent variable, first we put the name of investment and export. That's why first result is of investment and second result is of export. But now it will be reversed. Just you click enter. What is happening? In the first case, investment was first variable, but here export is the first variable, right? Understood?
Understood, sir. Understood. Thank you.
Yes.
So there is no change in the results as such.
No, there will be no change. Only there will be the shifting of the variables.
Yes, sir.
There will be no change. So this is our OLS, ordinary least square, or pooled regression. Now I will start the main discussion. Whether this type of OLS model will be accepted by us or not. And how can you judge whatever the regressions model has come out, whether this regressions model you will accept or not? That is the very vital point. So we have to interpret all types of result. But before interpreting all types of result, we must know what are the basic characteristics or the good characteristics or the good features of a good regression model that we must understand. And after that, we will be able to interpret all the results of our OLS. So one by one I will discuss, just minimizing it. I'm just coming to my PowerPoint presentation. This is your first slide that we have already done. How to run OLS, I have mentioned the command, and I have also mentioned the alternative command, regress, income, investment, export. This is done. Now we are coming to our third slide. What are the features of good regression model? What are the features? And I have mentioned the 6 important features of a good regressions model. So one by one, we have to check whatever the result we have got. All these results are reliable or valid or not. So first is regression must be fitted strongly to our data that will be reflected by R-square value. And it should be greater than 0.60. So what is its implication? The R-square value. And the R-square value, it must be greater than 0.60. The R-square implies total explanatory power. Again, I am saying total explanatory power of your independent variables. Total explanatory power of your independent variables. So explanatory power means with the help of these independent variables, you can explain the fluctuation or the variation of your dependent variable. Because when we are establishing any regression equation, our intention is with the help of our independent variables, we have to explain the variation that has been occurred to the dependent parameter. So what would be the minimum explanatory power? It is our thumb rule. It should be greater than 60%. That is 0.60. So now we are going to our software result. This is our software result. And you follow that the value of the R squared, it is 0.71. So from this result, you can say that with the help of export and investment, you can explain 71.70% of fluctuation of income. Again, I am saying, with the help of independent variables. So we have considered two independent variables, and with the help of these two independent variables, we can explain the variation, we can explain the fluctuation of our dependent parameter, that is income. So how much explanatory power we have? We are explaining 71.70, that means about 72%. Now the question is, why we are not able to explain 100% of the fluctuations of the dependent parameter? The logic is that whatever the good research we can do, you may also claim your research is very good, although you cannot say that you have taken all independent variables into your study that can explain 100% fluctuation of dependent parameter. In our social science, there will be no such research where you can say that your R square value is exactly equal to 1. If your answer is 1, then obviously there will be some doubt on your research work. So the question is, when we established any regression equation, some part of the fluctuation, it cannot be explained. It will be unexplained. So we can say that there are obviously certain other factors apart from our two independent variables. Other variables are also there. And if we can consider all the other variables into our study, then we can explain 100% fluctuation of our dependent parameter. And that's why if we are not able to explain 100% fluctuation, therefore we call it unexplained part, we call it as residuals. So residuals is nothing but the impact of other independent variables that has not been considered into our present study. So sometimes in some books, that's why it is called as error term, error term. So the thumb rule is that the value of the R square, that means your explanatory power, it must be more or less greater than 0.60. This is one of the important feature of good regression model. It might be OLS model, it might be fixed effect model, it might be random effect model. Whatever the model you are establishing, first you have to check the value of the R square. Now again I am minimizing it. Now we are coming to our second discussion. It is written here, at least minimum 50% independent variables should be individually significant, not jointly, should be individually significant. To explain,
Sir, the
yes,
variables which have not been considered in our study, so those variables are known as residual variables.
yes, these are called as residuals, right?
Okay.
Not variables. These are called as residuals, or it is also known as error term.
Okay.
Yes, that is called error. So error means what? Error means our yes, our observed value and our expected value. The difference is called error, right? Your
Okay,
actual value, and your predicted value.
Correct, sir.
So if the difference is there, obviously that difference is called error.
Correct, sir. Correct.
Right. So the second is at least 50% of independent variables should be individually significant to explain the dependent variable. Now, how can we know our individual independent variable is significant or not? That's why we must use the T statistics. So the value of T stats, it must be significant. Must be significant means in our software, the significant means the probability value, it must be 0.05 or less than 0.05. So just I'm coming to the result of our software. Yes. Now is follow this. Two independent variables we have got. We have got two independent variables. One is export, another is investment. So what value we have to observe? The T value. This is the value of T. This is the value of T. So T value is, in case of export variable, T value is 3.19. But more important is to check the value of probability. This is the value of the probability of T. The probability value is 0.024. That means it is less than 0.05. Therefore, we can say that the value of T of export variable is significant. right? The value of t in case of export variable is significant. And what is the thumb rule? If the value of t, if it is 2 or more than 2, then obviously the p-value will be significant. But what is happening in the second case? In case of the investment variable, the t-value is minus 1.33. That means less than 2. And what we are observing? Yes, the p-value is not significant. The p-value is 0.24. That means it is greater than 0.05. Greater than 0.05. So what we are observing? We are observing out of these two independent variables, one variable is statistically significant. You will report in this way, statistically significant, because the probability value is less than 0.05. But the investment, this independent variable is not statistically significant as the probability value is greater than 0.05. And what is happening in case of constant? The coefficient of constant is this, but the t-value is 2.93 and the probability value is 0.03. That means it is also less than 0.05. So your constant is also statistically significant. Your export is also statistically significant, but the investment, it is statistically insignificant. But what is our feature? Now I have mentioned the feature. The second feature, at least 50% of the independent variables should be individually significant. This is also true in our case because we have taken two independent variables and 50%, at least one variable, it is individually significant to explain our dependent variable. Hence, t stat must be significant. So in case of one independent variable, our t statistic was significant. So we are also complying with the second features of regression model. So first one is we have checked, yes, and second one we have also checked. Now we are coming to third point. Independent variables should be jointly significant against dependent variable. Hence, F statistic should be significant. So, what is the implication of F? The implication of F is there is a joint significance of your independent variable. So just we are coming to the result. You just observe the value of F statistics. The value of F statistic is 6.33, but when you are checking the probability value of F, that is 0.04. So it is also less than 0.05. So you can say that the F value of your regression model is statistically significant. It implies that there is a joint impact of two independent variables on your dependent parameter. But when you have checked individually, investment was insignificant. But when you are saying that if we club it, if we check the joint influence of these two independent variables on income, then your F statistics is becoming significant. The probability value of F stat is significant. So you can say that joint significance of your independent variables is being observed here. So third characteristic is also fulfilled in this model. Now someone may ask me the question, sir, is there any difference between R square and F? Because when we are saying the R square and when we are giving the interpretation, joint influence, jointly, it should be greater than 60%. That means with the help of these two independent variables, we are explaining more than 60% fluctuations of our dependent parameter. And in case of third, again you are saying that independent variable should be jointly significant to influence the dependent variable. So yes, there is a difference between R square value and the F statistics. Very, very big difference is there. And if you understand the difference, then you can easily say that which one is more important, whether R square value or the F statistics and its significance. Because most of the researchers, they basically rely on R square value. If the R square is minimum, then they confuse whether their model will be accepted or not. But my suggestion is the F statistics is better than the R square value. The question is why? Because R square value tells about your sample statistics. R square value tells about your sample statistics. That means whatever the sample you have taken into consideration in your study. But F statistics, it tells about the population parameter, not the sample statistics. That's why on the basis of the F statistics, we can say that whether our model is fitted or not. But on the basis of the R square value, we cannot say about the fitness of the model. If you want to know the fitness of the model, whether your model is best fitted model or not, that's why you have to check the value of the F statistics as well as whether the value of the F statistics is statistically significant or not. If the probability value is less than 0.05, if the probability value is less than 0.05, then you can say that yes, your model is fitted model. Now just we are checking again the value of R square. Yes, it is greater than 0.60. The probability value of F statistics, yes, it is less than 0.05. That means it is significant. And when we have separately checked the independent variable, then in case of export, the T value is significant. But in case of investment, the P value, probability value is not significant. But in case of the constant, your P value is less than 0.05. So it is also significant. So up to this, three characteristics have been fulfilled by this OLS model. Now the main question arises. Just yes. Now we should give more emphasis on point number 4, point number 5, and point number 6. And all these points are related with the residuals. That's why I have cleared the terminology. What is residuals?
Sir, can I ask a question?
Yes, yes, yes.
Sir, in that case, once we get the result, then first we should see the F value, whether it is less than 0.05 or not.
Yes,
rather
the
than,
probability value, the probability value.
Rather than seeing the R square value, because if the model, if the probability of F is greater than 0.05, then our model is not fitting.
Exactly, exactly. So first you have to observe the value of your F statistics.
Correct.
If it is fitted, if the probability value is significant, then your model is fit. Then you can say about another parameters, another points, right?
Correct. Because
exactly.
there may be a case when the R square value is 0.85 and the probability of F is more than 0.05.
Right. Then you cannot accept your model.
Right, sir. So I think probability of F is the deciding factor then.
Exactly. The model deciding factor is F statistics.
Okay, sir. Thank you, sir.
Very good question. Very good question. But most of the researchers, they are very much worried about the value of the R square.
Oh, actually, this is also my experience in many workshops. I have seen that they only look, oh, it is more than 0.75, 0.8.
Right.
It is very good model. But it may not be legally right.
Exactly. Exactly. Because R square is calculated on the basis of your sample. Hello?
Sorry, sir. Yes, sir.
Yes. R square is computed on the basis of your sample.
Yes, sir.
Right. But F statistics, it is based on the population.
But sir, when you say population, then but our data is based on sample statistics. So
yes,
but
on the basis of the sample, the software is predicting the population.
Okay.
Yes.
Okay. So it is extrapolating the data.
Just I am sharing one small story. Right.
Okay, sir.
Suppose you are going to purchase rice from the market, right? Sir. So there are various kinds of rice the seller is showing to you. Yes, but sir. You are just taking the sample, right? Not sir. The whole unit. You are just taking the sample, and after that you are predicting the quality of the rice. Yes, that sir. Means you are predicting on the basis of your sample.
Correct, sir. Correct. Okay.
So yes. Now 3 points. These are very, very important. One is checking of autocorrelation. Second is checking of heteroscedasticity problem. And third is distribution problem. That means normal distribution. Again, I am saying, because these 3 points are very, very vital point. So, when we have got the result of the model, up to this, we can only check the point number 1, point number 2, and point number 3. Right. But if you want to check point number 4, point number 5, and point number 6, then obviously you have to show your residuals, because all these assumptions about the residuals. So you have to compute residuals from your model, and after that you can check point number 4, point number 5, and point number 6. So now task is we have to predict our residuals. From the regression equation, we have to find out the residuals, and after that, we will check autocorrelation, we will check heteroscedasticity, and we will check whether our residuals are normally distributed or not. So one by one, I will explain what is autocorrelation and how autocorrelation will be checked. What is heteroscedasticity? The word is very complex, but the concept is very simple. Heteroscedasticity, this word is very complex, right? But the simple concept is there. And another is normal distribution. So these three things we have to check on the residuals. That's why now our next step, that is to form the residuals from our regression model. So now I'm again going to software. Yes. Now for preparations of residuals, again I will take the help of our statistics, preparations of residuals. Just go to statistics. No need to write any command because I have already given to my PowerPoint presentation. You just observe. Go to statistics. What we are doing now, we are going to prepare the residuals from our regression equation. Statistics, then, statistics, then you come to post estimation because you are doing it after the regression model is established. So you have to search after estimation. Post estimation, yes. The post estimation, that means after estimating the equation, our task is to prepare the residuals. So we are clicking here, post estimation. Now after post estimation, then you are going to predict the residuals. Here the term is given, residuals, predictions and residuals. Now just click here. Now the software is asking you please give a name of residual. So you may give any name of your residual. First I am giving here U. Type here U. So U is your name of your residuals that will be created from your regression equation. Now you just select residuals, yes, residuals. Now you click on OK. So again I'm saying, first you have to go through statistics, then coming to post estimation because you are estimating after established equation. Then you are coming to this point, predictions and residuals. Click it. You are in the name of the residual, suppose U. Then you select the residuals. Then you click on OK. Yes. The residual has been already computed by the software. And the software is showing that predict U residuals. This is your command. If you directly write here, then the residuals will be also formed. So after the preparing the residuals, now we are ready to check the normality, to check the autocorrelation, as well as to check the heteroscedasticity. So first I will talk about normality. First, I will talk about normality. So, the features of a good regression is the residual value. Whatever the residual values we will get, that must be normally distributed. You know that the shape of the normal distribution, it is bell-shaped, bell-curved. So if your residuals are normally distributed, then this is the good feature of a good regression equation. So the first checking point is your normality. Now, when we are going to check the normality, you just think about your SPSS software for checking the normality. What about the statistics we used? Generally, we use various types of statistics to check the normality of your data. But here we are checking the normality of our residual. Residual is also one kind of data set. We are going to check the normality of our residuals. In case of SPSS, one popular test was Shapiro-Wilks test. Shapiro-Wilks test and KS test, as well as graphical representation, that is histogram. Through histogram, we can also check the normality of our data. As well as in case of SPSS, we use the value of skewness, the value of kurtosis. Many options are there. But in case of our Stata software, the popular command that we use for checking the normality of the residuals, the name of the test is Shapiro-Wilks test. Shapiro-Wilks test is the popular test to check the normality of our data. Now I will show you how to check the normality. Just you go to statistics, then go to this option, summaries, tables, and test. Summaries, tables, and test. Now, normality is a question about the distribution of your data set. That's why we will click on distributional plots and sets. Again, I'm saying, as the normality distribution, it is a question about the distribution of your data set. That's why we are clicking on summary, table, and test, and under it, we will click on distributional plots test. Then we are coming here. Then you search of your popular test, that is Shapiro-Wilks test. Yes, Shapiro-Wilks normality test. Just to click here. Yes, the software is asking, please specify your data set. So our data set is, we are going to check the normality of our residuals. Therefore, we will give the name of our residual, that is U. Just click here. Yes, U is there. Now you just click on OK. You just click on OK. Now the result is appearing here. Shapiro-Wilks test for normal distribution or normal data. Now the question is, which value we have to check? The last value you have to check, that is the value of the probability. And listen very minutely. For checking the normality, first we have to set our null hypothesis. When you are going to check the normality, when you are going to check the heteroscedasticity, as well as when you are going to check the autocorrelation, we have to assume a particular hypothesis, which is null hypothesis. And here, the null hypothesis is your residuals are normally distributed. So your null hypothesis is yes, your residuals are not normally distributed. An alternative hypothesis is your residual is normally distributed. So your data set is normally distributed, that is your null hypothesis, and your data set is not normally distributed, obviously it will be your alternative hypothesis. So whether you will accept your null hypothesis or you will reject your null hypothesis, it depends upon the value of the probability. It depends upon the value of the probability. Again, I am saying the value of the probability that must be greater than 0.05. That must be greater than 0.05. So here the value is 0.17. That is your probability value is greater than 0.05. When this value is insignificant, in this case, the probability value must be insignificant. And your null hypothesis is your residuals are normally distributed. So if this value, if the probability value, if it is greater than 0.05, it is greater than 0.05, then obviously you will accept your null hypothesis. So you can say that your residuals are normally, approximately normally distributed, because no data is super normally distributed. That's why we always use the term approximately normally distributed. We'll never say absolutely normally distributed. We will say approximately normally distributed. So you will remember in this way, if this probability value is insignificant, that means if it is greater than 0.05, then you can say that your residuals are approximately normally distributed. And if you type the command, then also you can get the same result. Shapiro-Wilk, S-Wilk, Shapiro-Wilk of what? Of your residual U. Just click here. This is the small command. S-Wilk, Shapiro-Wilk of your variable name. So your variable name is here, residuals name is U. So you are just giving this command S-Wilk U. You will get the same result. You will get the same. This result is, this is your initial result, and this is the result that we have got after giving this command S-Wilk U. The same results you are getting. But the problem is that if you only remember the command, then the logic you cannot understand. So my suggestion is use this option statistics. Use this option statistics. So again, I'm showing. You go to statistics. Yes.
So in this case, the null hypothesis was the residuals are approximately normally distributed.
Normally, yes.
And alternative was the residuals are not approximately normally distributed.
Exactly.
Okay, sir.
Exactly.
Okay, sir.
And your probability value is what? Probability value is insignificant.
Because it is more than 0.05.
Right. So as it is insignificant, that means you cannot reject your null hypothesis.
Correct, sir. Correct. Yes, sir.
Right. Yes. So just I'm showing statistics, then summary tables. Then you just go to distribution plots. Then directly you are coming to Shapiro-Wilk normality test. In this way, you will follow it. Then you have already given the name of your residuals. Okay, so you will get this result. Now the second is, fifth objective is checking of heteroscedasticity problem. I am just clearing the term, and after that I will show how to check the heteroscedasticity. So,
Professor Biswas, just a
yes.
question, sir.
Yes, yes.
Sir, normally when you check normality, we usually check the normality basis on the data set, right?
Yes.
So what is the value of checking the normality of the residual, sir? Why do we do that specifically?
Exactly. The very good question that you have raised. In case of what you are telling, generally we check the normality of data set. You are absolutely correct, but it is done in case of your cross-sectional data, not in case of the time series data, not in case of the panel data. Clear? This is the first logic. And the second is, when we are using the time series or panel data, whatever the residuals we are getting, we are very concerned about the residuals, because all these are the predictive model.
Sir,
So
what
whether
is the question of Gautam, sir?
What is the?
What is the question put up by Gautam, sir? I could not understand the question.
He has put it the question. So generally we check the normality of our data set.
Correct,
Why?
sir.
Yes. Why you are checking the normality of the residuals?
Right,
now
sir.
I am giving yes. Now I am just clarifying it. In case of the cross-sectional data, we generally use the normality checking of our dependent parameter as well as independent parameter, but not the residuals. But why we are checking the normality of the residuals? Because you are trying to establish a good predictive model. So whether your model is good predictive model or not, these are the assumptions. If you violate these assumptions, then you cannot say that your established model or your predictive model is the best fitted model. That you cannot say, right? So that's why not only the normality, we have to also check the autocorrelation, we have to also check the heteroscedasticity of our residuals. We are not worried about the dependent data set or independent data set. Okay.
Sir, one
Yes.
question is there. Suppose our probability of F value has come down below 0.05 and our R square value is also good enough, about 0.60. Then
Exactly.
why should we worry about residuals then?
Yes. When F stat will not be significant, then obviously you will not check all these residuals, because initially your model is not predictive model.
No, sir. Suppose based on these two parameters, two independent variables, export and investment, we have got the R square value 71.7%.
Very good.
That means 71% of the fluctuation in income is explained by these two independent variables.
Exactly.
And the model has also been decided very good based on the probability of F value.
Exactly.
Sir, then why should we worry about residual factors, sir? residual
Yes.
variable.
The question is that when we are trying to predict the model, we have only considered about two independent variables, but we have not considered the other independent variable.
But sir, my question is, why should we
Acha,
consider?
shall I try this answer, Dr. Biswas?
Yes, yes, yes.
Acha, Sadhvir ji, go to the assumptions of the classical linear regression model. You will find that in the books of Gujarati, you have to satisfy all the 10 assumptions. Maybe if you don't satisfy 10 assumptions, maybe 8 or 9. Only with the satisfaction or the completion of the two assumptions, you
Right.
cannot say your model is fit. Now, Dr. Biswas will also tell us about the heteroscedasticity, autocorrelation. These are also required. You cannot say
Exactly, exactly.
you only have an indication that the model is good and fit, but
Okay.
not the entire certainty that it is acceptable.
Right.
Okay, because
Am I-
Rohit sir, you are right, because so far I have not come across beyond these two parameters, not even F value, based on R square value.
No. These are good.
Towards the target.
These are the good indicators that your model is going to. Maybe your model is going to be. These are indicators and not the complete results. For the complete
Right.
results,
All the points you have to satisfy.
But sir, Devanshi sir, the question is, when we have
Yes.
when we have reached 71% in our results, that okay, these factors are explaining 71% of the problem. So the balance 29%, which is less, which is in minority, why should we worry about those independent variables, which may be many in numbers, which may consume a lot of efforts and money
Yes.
to explore?
Yes. I'm giving you another point of view that can be explained.
Okay.
Suppose whatever the data set you are taking into consideration,
Yes, sir.
if there is a high probability of autocorrelation, that means suppose you have taken the value of income, and
Yes, sir.
whatever the values of income you have taken into consideration, all the values, suppose they are correlated with each other.
Okay.
So you cannot say that your regressions model is very good. Because when you are considering one particular variable and all the values of the variable, they are interrelated with one another. That means there is a problem of autocorrelation. So you cannot say that whatever the regressions model on the basis of the R square, on the basis of the F, you have fitted, that is absolutely correct.
Okay.
Got my point?
Hello.
Sir, Biswas sir is raising the hand.
May I
Yes,
intervene?
sir.
Hello.
yes.
Well, always come.
Hello. Actually, when we use econometric technique, then we should understand that there are some assumptions of classical linear regression model, and one of the assumption is that there should not be any type of heteroscedasticity. There should be not a problem of autocorrelation. There should not be any problem multicollinearity.
Right.
So we have to test all these assumptions. Otherwise, our OLS estimators will not blue. And in this situation, our model is not good.
Exactly.
Only maximizing R square is not useful. It is clearly mentioned in Gujarati's book that maximizing R square is not a useful technique.
Exactly. You
Yes.
have to satisfy
So,
all
sir,
these
Biswas sir,
conditions.
it is a new realization for me.
No. No,
Because
it is basic. It is first step toward estimating an econometric model.
Okay, sir.
Otherwise,
Now,
you
thank
cannot.
you, Roy sir and
Yes, sir. Otherwise, you cannot claim whether your predictive model is very good.
Only
Okay, sir.
fitting the model and getting R square is not a useful technique. Even when R square is below 0.20, I think the model is very good in the case of cross-section data.
Exactly.
Okay. Nice. So it is a new realization, sir. Thank you, Biswas sir.
No. Thank you.
Okay, thank you.
Okay. So in this way, we have to check the normality distributions, whether our residuals are normally distributed or not. And after that, we are going to check the heteroscedasticity problem.
Hello, may I intervene?
Yes.
Professor Saab is going in right direction, and I think that we should try to understand what he is teaching.
Thank you,
Right,
sir.
right.
Thank you.
No, it is nice, sir. It is nice because
Thank
so many times the professors, other professors, they focus only on R square, not even on probability of F value. So, Bisnoy sir, you are perfectly right that we should listen to Dr. Biswas 100%.
We should try to understand what he is trying to explain, and he is going in very direct direction. And I have been teaching experience of 40 years of econometrics. I am professor in head of department. Even then, I am learning.
नहीं सर, हम भी
you,
आपके
sir.
साथ हैं
Thank
सर.
you.
We will learn with you also, sir. Thank you.
Thank you, sir. Thank you. So now the question is the checking of heteroscedasticity. In a very simple way, I'm just trying what is heteroscedasticity. Just I'm giving an example. Suppose consider here variable. One is some of individuals. So what basically happens, we know that the consumption, it depends on our income. Consumption is depends on our income. Now your intensity is to predict the level of consumption. So your consumption is your dependent parameter, and with the help of income, you are just going to predict the consumption's level. But sometimes your predictive model may be failure if there is a problem of heteroscedasticity. Now the question is, what is then heteroscedasticity? Suppose I am saying when the income level is 10,000, suppose income level is 10,000, then the consumption is 8,000. But when the income level is 50,000, when the income level is far higher than the 10,000, then the consumption level, if you predict the consumption level will be 20,000, it will not be correct all times. Because when your income level is higher, then there will be the variety of the consumptions level. Suppose my income is 50,000, but my consumption is 20,000. But another's income is 50,000, but his consumption is 30,000. Another's income is 50,000, but his consumption is 40,000. So many, when your income is raising, so many options of consumption is coming on. So if you directly predict that if the level of income is this, and so that the consumption will be only 30,000, so your result may not be right. So that means your data set, there is a problem of heteroscedasticity. So that's why it is also very essential to check the heteroscedasticity problem when we are going to establish any type of regression model. So now I will show how to check the heteroscedasticity in Stata software. Just for checking the heteroscedasticity, I'm just taking the help of the statistics option, and shortcut option is also there. I will show you the alternative options. Just you go to statistics, then linear models and related. Now the question is not about the distribution of your data. We are not talking about the normality distribution. We are talking about the diagnostic checking. That's why we have to click on the option regression diagnostics. Then just click on specification of test. What types of test you are wanting from the software? You have to specify the test. So just you click here. Yes. Now you go for heteroscedasticity checking. Heteroscedasticity test for heteroscedasticity. Yes, the first one, the test for heteroscedasticity. Just you select here. Just you click on OK. Yes. The result has already come. And here also, you have to check the value of the probability. Here the value of the probability of chi-square, the value of the probability of chi-square, it is also greater than 0.05. It is also greater than 0.05. Here also we are making the assumptions of our null hypothesis. The assumptions of our null hypothesis is our residuals are free from heteroscedasticity. Free from heteroscedasticity. That means our residuals are homoscedastic. Therefore, as the probability value is greater than 0.05, therefore we will accept our null hypothesis, and we can infer that in this case there is no problem of heteroscedasticity in our model. So in this way, you have to check the heteroscedasticity, and one alternative test is also there. Just you go to the command, then heteroscedasticity is stat hetero het test, heteroscedasticity test is that HET test. Now just click it, then you will get the same result. You will get the same result. Alternative is there, then you can get the same result. Here it is also 0.3874, and here it is also 0.3874. So in this way, you can check the heteroscedasticity problem. So the fifth assumption is there will not be any heteroscedasticity problem. And the last one is we will check autocorrelation. Sorry, fourth number point. This it was because we have already checked the normality, normal distributions as well as heteroscedasticity problem. The last one is the residuals will not be autocorrelated. Therefore, we have to check the autocorrelation problem. And what is autocorrelation? That I have already explained some time before. So just I'm going to the software. Just going to the software. Then yes, just go to statistics. Then
I think we lost connection.
I think Sadhbir sir lost connection. Sorry, Devashik.
Ma'am, I am connected to you.
Actually, sir, अभी से बार-बार याद आता है.
नहीं आज हमको लगता है उनका थोड़ा इसमें इंटरनेट में थोड़ा प्रॉब्लम भी है, कभी-कभी वॉइस क्रैक कर रहा है.
Even the last exercise also I could barely hear it. The audio was very poor.
It's today the net connectivity is a bit poor, on the poor side. I also say.
Correct, Ji. Correct, Sadhbir.
But maybe he's not aware that he has lost the connection. Maybe.
No issue. Shivangi ma'am will connect to him. Rosa, where is he based? Devasi sir?
He's from Vidyasagar University. You know about Ishwar Chandra Vidyasagar? Do you know about him?
Yeah. I know. Our legendary historian.
So he belonged to Midnapur district. So Vidyasagar University is in Midnapur district. Though that district has been divided now, but he's in that university.
I was in Midnapur in Haldia for 6 months in 92.
That is in now the West Midnapur, and he's now in the East Midnapur. Previously Haldia was also in the Midnapur.
It is still in West Midnapur, right? East Midnapur. Now
Haldia is in West Midnapur, but the Vidyasagar University is in the East Midnapur.
Okay, sir. I used to go from Macheda to Haldia, from Howrah to Macheda.
Yes, okay.
On the way to Kharagpur, and then from Macheda to Haldia by highway road. I was in Indian Oil Corporation earlier.
Okay, okay. Okay, there's a refinery.
Sorry to interrupt. I just had a call with him. He's trying to connect. Some network issues there in his side.
Okay.
Yeah.
No issue,
His
we'll
phone
wait.
is also not reachable. We have texted up and
No,
talked.
we will wait. We will wait.
Okay, sir.
It's not an issue. Sadhvir ji.
Yeah, we will talk. We will talk later, sir.
No, sir, he hasn't joined, I think. Let him join. Shivangi ma'am,
Yes, sir.
there's another participant. I think he's also from Africa. I think I cannot pronounce his name exactly. It's something like Omphile Kekoti. Huh?
Yeah, sir. Yes, sir.
He's from I think Africa, na?
Sir, he's from Africa. He has not written his country name. He's some faculty there in some institute. I'm just telling you all.
Okay. He has now unmuted himself. Huh?
No issue. Let him tell about himself. Mr. Omphile, can you please explain about you?
He has listened. I think he has unmuted himself also.
Yeah. Mode, he's your friend? No, we are not able
No, I don't know him. He's talking. He's online now. So let's hear from him.
Okay.
But he's from Africa, I know.
No voice. Raise your voice.
No. I think he has put on his headphone, but not the jack.
Sir, he is from some Botswana accountancy college.
Okay. Am I audible?
Yeah. Yes, you are audible now.
Okay. All right. My name is Umpile. I'm from Africa. He guessed. I'm from Botswana.
Okay.
Oh, fantastic.
Yes. Unfortunately, unlike my friend, I've never been in India, but my brother have been there. So I just saw this from the group, and then I thought it might be good to join. I'm actually doing my master's with MSU University in Zimbabwe.
Okay.
And I'm also a development lecturer here in Botswana at Botswana Accountancy College.
So, sir, how you are liking the work?
It's going so well. I've been following very well today without any distractions, and I think Professor is leading us very well, and I can really understand what he's saying. The only thing that will be left is to be putting into practice what I'm learning here.
Okay. So you are satisfied with the workshop and with our faculty, with the resource person?
I didn't get that one clearly.
Sir, I'm saying that are you satisfied with the resource person? No, you are satisfied with the resource person.
Yes, please. Yes, I am.
Mr. Omphile.
Yes, sir.
Hope after completing this workshop, you will take the next workshop on this panel data analysis.
Okay. I want to do that.
So you can explain. So you can teach us next time. For our
yeah, I I can try that, but it will need some practice. Maybe after 2-3 years, I can be able to teach you.
That is your business. That is your business. You do whatever you want. But next doubt clearing session next week we can have with you. Shivangi ma'am.
I'm not sure about that one.
Shivangi ma'am,
sir, I'm there.
am I correct?
Yes. My worship person will be Phil sir only.
Yeah. Good. Thank you. Ma'am, sir is coming or?
Sir, his phone is also not reachable.
Oh, there might. Now he joined.
Yes.
He just joined now.
He's 100 years. He's more than 100 years.
Due to network problem. Okay, so just again presenting.
Roy sir was entertaining us along with
No.
Mr. and others.
Very good. Very good. Yes. Now, for auto-correlation purpose, we are coming to statistics. Then as our data is time series data, therefore, we are click on time series, setup and utilities. You have to declare your data set to be time series data. Then only you can perform the auto correlation test. Then just click here. Yes, time variable. Your time variable is observation, OBS time variable. Then yearly observation is there, so you click on yearly, then you just click on OK. So now your data set, the software has taken as time series data. So test OBS observations yearly and time variable observation 2001 to 2008. Now you can perform auto correlation test. The same logic, you have to go to statistics, then linear models and related. Then as it is also regression diagnostic checking, then go to specification test, then click here, then just you search Darwin Watson test. Yes, these tests you have to select Darwin's alternative test, Darwin time series only, just you click here. Yes, just you click here. Now you click on OK. Yes. Now again you have to also observe the value of the probability. Here also the same thing. The value of the probability, it must be greater than 0.05. So your null hypothesis is there is no auto correlation. There is no serial correlation or auto correlation. The same thing. There is your null hypothesis is there is no serial correlation, or you can write in this way, your null hypothesis is there is no auto correlation. So as your probability value is greater than 0.05,
Hello.
therefore, yes.
Hello, sir. All the coding for the autocorrelation, I did not get anything because I didn't see the presentation on my screen.
No, we can see. Maybe you have to.
It has just come. I didn't see the step by step autocorrelation.
Okay. Again, I'm saying. So when we are performing the test, I'm showing this. Go to statistics, then linear models and related. The same logic, linear models and related. Now you choose this option, diagnostic checking, regression, diagnostics. Then come to this point, specification test. What types of test you want? You want Darwin-Watson test. So you select here Darwin-Watson test time series only. Now you just click on OK. You are getting the result of probability. You just focus on this result. And what is your null hypothesis? Your null hypothesis is there is no serial autocorrelation. This is your null hypothesis. As the probability value is greater than 0.05, so you may accept this null hypothesis, and you can also say that your data set, your residuals, it has no serial correlation or there is no auto correlation. In this way, we can also satisfy the condition, that is residuals will not be auto correlated. One direct command is also there, direct command. The same logic, estat, then Darwin, DURBIN, Darwin ALT, alternative, ALT. Then just you click here, you are getting the same result, that is 0.5542. So in this way, if your regression, if your OLS or your fixed effect model or your random effect model, the same thing, you have to satisfy all these 6 basic assumptions of a good regression model, so that you can claim that your model is very good predictive model. So I have already given the command, you just practice it. Features of good regressions models I have mentioned, and after that one by one, normality checking, heteroscedasticity, and auto correlations of residuals. First, we will prepare the residuals with the following command that I have already shown, and the result residuals U will be created. An alternative command is this, and after that you can check the normality. The command I have already written, an alternative I have already written. Then after the normality, then you can opt for heteroscedasticity. For checking the heteroscedasticity, command is given, alternative command is given, and here this is the result. This is a very vital. If P is non-significant, that means non-statistically not significant, then you may say that your residuals are not heteroscedastic. That means there is no problem of heteroscedasticity. As well as for checking autocorrelation, I have mentioned the command, and there is the alternative command, and the same result. If the P is non-significant, then you can say that your residuals are free from any type of autocorrelation problem. So you have to check the autocorrelation, you have to check the heteroscedasticity, as well as you have to check the normality and other 3 assumptions. Then you can say that your OLS or ordinary least square model is appropriate in your study. In this way, you have to report all these results. So in the next tomorrow's session, I will focus on other 2 models, that is fixed effect model as well as random effect model. So first thing is you have to understand the assumptions of the regression, then we can easily understand all the fixed effect as well as random effect model, and after that we will take the decision which model is comparatively better. Suppose all models are satisfied these conditions, but the question is which model is better, whether your normal OLS is better, whether fixed effect model is better, whether random effect model is better. That choice, that selection must be made. So therefore, tomorrow's session is very, very important. And in the 5th day session, I will just recapitulate all these things, taking a problem. So thank you very much for your kind attention.
Sir, can I
Yes,
ask a
I'm
question?
coming. Yes.
Before this test of autocorrelation, you selected the variable OBS yearly. What was the purpose of that command, sir?
In case of autocorrelation,
Yes, sir.
basically autocorrelation in this data software, if the time series you take, then obviously you have to declare whatever the data set you have imported into the specific software, that is time series, because software cannot understand it until and unless you will specify it. That's why you are giving this command, the data set declared to be time series data, right?
Okay, understood. Thank you, sir. Thank you.
Thank you.
Sir, one question I would like to ask.
Yes, sir.
So actually, you used Durbin's alternative test.
Yes.
But there is also Durbin D-test statistic.
Yes.
So which test is to be used in which situation?
Right. Basically, Durbin D-test we can also use, but in this our specific software, that options is not available.
Okay.
Right. That's why we are taking this option alternative. We are using the term alternative. Right,
Okay.
Welcome, sir. So, anyone, please. So today all participants have not joined.
No. I think a lot of
it is showing 13. Except Shivangi madam, it is 12.
No, they were, I think at one point of time there were 15-16 participants were there.
No, basically Prasenjit Babu, basically the thing is that if you miss 1 day session, then total 5 days session is meaningless to you.
Yes. That is true. That is true, because tomorrow nobody will understand whoever missed out today's session.
Exactly. Because one session is related or connected to another session.
One good thing is that we could had a talk with another participant from Botswana, because while you were disconnected, his name is Om Phaile, I think. Can you please unmute yourself? And yes.
Yes, I just. Hello, Professor.
Yes, you are from which place, sir?
I am from Botswana.
Okay.
Yes. One small country in Southern Africa.
Yes.
Good.
Yeah.
So are you following our accent?
I didn't get that one.
Yeah, whatever we are communicating, you are able to understand all these things?
Yes, I'm following very well. I've been taking notes as well, so that where I have some problems, I can always refer back.
You are a very good student also then.
I'm an old type of a student, old-fashioned. I take notes myself.
Very good.
Yeah.
So
I think everybody understood.
Okay, no problem. I will send the necessary notes of today's session to Shivangi madam, and she will distribute to you. Okay.
I think she's going to say something. Ma'am, are you going to say something?
No, sir. I was just listening what you all were talking it out.
Okay.
Very good.
So the participant from Pakistan also didn't join today, na?
No, sir. She has not joined today. Also, some issues are going in the country, I think, so that's why she is not able to join it out.
Okay.
Yeah, because she's not available on her WhatsApp also, and neither on Messenger. So some internet issues are going on, I think so.
Right, right.
Yeah,
Yeah,
yeah.
Madam Shivangi, madam, can you tell us about the YouTube channel that you've been talking about, madam?
Yes, my YouTube channel is
Watching
present
the-
there. All the recordings would be updated there. It takes time to edit the recording. So once it's being recorded, I would be
Right.
sharing it with you all.
Yeah, that link will be shared to us, right? Right,
Yeah,
madam?
yeah.
Yes.
Day-wise link would be there. You can subscribe my channel. You will get all the recordings there only.
Okay, okay, madam. Thank you.
Yeah, sir.
Okay, thank you very much. So today we are closing the session, madam, with your kind permission.
Sure, sir. Sure.
Okay, so see you tomorrow.
Thank you, sir.
Okay,
Good night, sir.
thank you. Good night.
Thank
Good
you,
night.
sir.
Yeah, yeah.
Good night.
See you tomorrow. Okay, welcome, welcome.
Good night.
Welcome.
Good night.
Good night.